Hey there, welcome to another episode of the Blockcrunch podcast, and yet another episode in the 500 Blockcrunch mini-series, a series that I'm launching with Seed Stage Fund 500 Startups, where we talk about all things crypto scaling. So if you're a developer or an experienced investor trying to dive deep into what scaling actually is, as well as what some world-class teams are working on today, then this is the only show that would give you that information in 30-minute segments. And in the past week, we've already covered every single major type of scaling challenges that blockchain projects are facing, as well as the different tiers of solutions that world-class teams are working on. And we covered all of that in an episode that I did with venture partner from 500 Startups, Bonnie Chung. So if you want a primer on all of these different types of scaling solutions, definitely check that out. And we also got to talk with some world-class teams as well, including Solana and Seller Network, both of which are funded by 500 Startups. And today we're talking to another team called Connext Network, and they're backed by Kinetic Capital out here in Hong Kong. And what they're doing is essentially a layer on top of the blockchain backbone. They let you set up and use a state channel hub, and they have already partnered with SpankChain, a blockchain built for adult entertainment. And I've met Arjun Bhuptani, the co-founder of Connext, actually back in a development bootcamp that I was in about a year ago, before they pivoted from the original iteration. Now they're completely focused on allowing developers to build scalable dApps on the Ethereum blockchain through these state channels. And if you're a blockchain enthusiast and you're tired of hearing people explain state channels as if they were just bar tabs on the blockchain, which is theoretically correct, but a pretty simplistic explanation, and you want a more nuanced and deeper explanation of how state channels work and what the current state of state channels are, no pun intended, then this is a perfect episode for you because Arjun and I do get really deep into state channels, and I myself learned a great deal from this episode alone. So without further ado, I'm really excited to share this conversation with you. But before we get started, I wanted to give a quick shout out to our friends over at Global Coin Research, who produce one of the most comprehensive newsletters every week covering all things crypto in Asia. And if there's one thing that I realized after coming back to Asia, it's the fact that a lot of exciting developments and teams here are not really covered by Western media. So if you want to stay abreast of the industry as well as stay ahead of the market, then Global Coin Research really is one of the best newsletters that you can subscribe to. And you can find them at globalcoinresearch.substack.com, or you can simply Google Joyce and Global Coin Research. Now, without further ado, let's jump right into my conversation with Arjun Bhuptani from Connext.
This is this worldwide phenomenon.
Hey Arjun, just to get us started, can you talk about how you got into crypto?
I was originally doing physics, found that, for theoretical physics, found that there are really no jobs in theoretical physics, and kind of wanted to do something a little bit more practical. And so after I graduated, I moved to San Francisco just on a whim, ended up getting introduced to Ethereum through some friends, had a pretty big interest in like universal basic income and things, and like democratized payments, things like that. And so ended up getting sucked in, as I'm sure most other people do.
That's awesome. And I know that after that you started working on Connext. So can you kind of discuss a little bit about the story behind that, how you came up with the idea and how you assembled the team behind that?
So we originally started Connext, I think it was like April of 2017. Back then I had kind of worked on a few other projects in the space, just like informally, small things, nothing that it kind of is still around. But what I found was that there was this big underlying assumption for a lot of companies, which was that they expected that their users would be able to easily get access to a token in order to use the dApp or system. And at the time, it was like really difficult to do that because there wasn't really good exchange infrastructure and because the process of actually getting access to those tokens was ridiculous. So we started Connext initially as just a way to build technology that lets people buy tokens directly with credit cards. Now, that was kind of before all of the ICO craze took over and all of the hype started. And so pretty soon thereafter, a lot of people started to, we thought that the space was expanding because we saw tons and tons of people issuing tokens. And we started to see some interest from like card networks and banks in providing that sort of solution. But unfortunately, it took a lot longer than we expected for most people to get to market. And so earlier this year, in like around February, we looked around and realized there was only a handful of use cases that were actually active, and most importantly, the bigger problem that they were facing was associated with scaling and not with mainstream adoption. And so initially, we kind of pivoted to state channels or like payment channels initially just as a way to solve this problem for our customers, and that way we could get them to the point where they needed cards faster. But since then, we've found that this is in and of itself an extremely valuable thing, and that using a combination of stable coins and like tokens and like a payment channel or state channel network, you can recreate a lot of the experience that exists with like Visa, MasterCard, or other like card networks today. And so that kind of is the new goal, is let's democratize the process of being able to pay anybody.
And we'll definitely dive into what you guys are working on right now, which are state channels. But first, I'd like to ask you kind of like a high-level question. On this show, we talked a lot about scalability solutions in crypto. We talked about the networking relayer level, which is kind of the so-called layer 0. We talked about layer 1, which includes things like sharding or new consensus protocols, as well as block size increases and things like that. And we also talked about other layer 2 solutions like sidechains and so on. So I'm curious as to why you decided to focus on state channels. What about state channels makes you decide to spend the majority of your time on right now?
First off, I'll start out by saying the scalability in Ethereum and in blockchains is a really, really complex set of problems. And it's not just one thing. It's like this set of characteristics of blockchains that have to be like solved for. And because of the way that scaling solutions work, there's no kind of like silver bullet solution that's going to fix everything. Each and every different type of solution has its unique benefits. So there's things like Plasma and sidechains or plasmified sidechains. Those we found tend to be really useful for like multi-party systems where there's like a bunch of different people who are interacting that all need access to the same information. Really useful for things like games or like multi-party payments or like ecosystems where you're sending something into a contract and a bunch of other people are like querying that contract or something like that. On the other hand, the use case that we ended up being more familiar with just because of what we were doing initially was something like interactions that are peer-to-peer, just directly happen between two people or at least can be boiled down to an interaction between two people.
So what's an example of such a use case?
This includes like payments, exchange. It includes like some sort of like conditional payments. So that can be anything from like a subscription or up to blackjack. Would be a type of conditional payment. And so what we found was that for those instances, payment channels or state channels are better. And the rationale behind this is that the fundamental difference between the two is that with Plasma, you have something that requires consensus. And so you have a consensus mechanism because you have, more than two people. And so you need those people to agree on something. With state channels, you don't have a consensus mechanism. You just have unanimous consent. So everything that happens, everybody agrees to. And that has very different trade-offs associated with things like finality. So like in a state channel or a payment channel, you can pay a person and it can be considered final. Like there's no way for that to be undone. And so you can kind of go on about your day without ever having to worry about whether or not you've received or sent that money. Whereas in Plasma, that's not necessarily the case. There are very different finality constraints. So as you can see, there's really it's just a different set of trade-offs. Some things will be better on Plasma, some things will be better on sidechain, some things will be better in state channels. People are still trying to figure out what falls into which camp.
So I think a really simplistic explanation, but very popular explanation of state channels is that they're almost like bar tabs for the blockchain. Essentially, you open these bar tabs and you don't have to worry about it unless you're opening the bar tab or closing the bar tabs. Those are the two only times you really have to commit to the blockchain and wait for confirmation and pay transaction fees. But with that also comes with the added difficulty that every time I want to pay somebody, I have to set up a payment channel with them. So how do you navigate these difficulties with Connext?
Yeah, I mean, you can fundamentally just think of a state channel as a way to like put whatever it is that you want to transact into a multisig. And after you put it into a multisig, you need signature from both parties in order to release it. Right? And because you've set up the system in that way, that means that you can effectively, quote unquote, pay somebody by just sending them your signature, like sending them a signed transaction, because then they can just sign the other half of the transaction and get the money themselves if they want to at any time.
So for people who might not have as much of a technical background, what Arjun is describing as a multi-sig wallet is essentially this. When you want to send a transaction on, say, the Bitcoin network, you need to sign the transaction with your private key. You need to sign it with your signature. And on a multi-sig wallet, it allows transactions to only be approved if the transaction is signed by multiple parties that are predetermined. So say I set up a multi-sig wallet with Arjun. Any transaction that I want to send Arjun, if every time I want to send money to Arjun, or any time that Arjun wants to send money to me, those transactions need to be signed by both of us instead of just one of us for it to work. And that's how these state channels work on a very fundamental level. So as you can imagine, every time that I want to transact with somebody, I would have to open a multi-sig wallet with them if I want to do it through a state channel. So this is pretty clunky from a user experience perspective, from a UX perspective. But Arjun's Connext has worked with SpankChain, which is a adult entertainment blockchain company, and they had to navigate some of these UX issues. So I let him talk more about that.
Now, as you mentioned, there are UX constraints around this. Opening and closing channels is a constraint, but that can be solved, and that's really just solved with like good like frameworks and like wallet usability. So for instance, how we do this with SpankChain is that SpankChain uses this thing called the Venus wallet, where when you deposit into the wallet in the first place, that just automatically opens a channel. And so for the user, you never even know that a channel has really been opened. It just looks like you're depositing into the wallet. A few other things that we kind of want to try are one thing that we have set up right now is just very easy to use NPM package that just sits on your front end, just kind of pops MetaMask whenever you interact with it. So whenever something happens, it automatically opens a channel using MetaMask, and you can sign using MetaMask as well. The other way to do it is to like integrate it natively into a wallet like Balance or something like that, and just have it look like a quote unquote checking account. So the user doesn't really know what they're doing. They're just kind of moving money into their checking account, and then everything that they pay from there is free.
It's cool that you mentioned Balance because I was just talking to the founder of Balance, Richard Burton, in a previous episode, and we talked a lot about the challenges that are facing users from a UX perspective. And I think it's interesting how Connext is abstracting away the lots of technical difficulties and obstacles and frictions so that users don't have to deal with opening these state channels in the beginning. And all they can really see on their app is essentially just a wallet app. And they'll never know that, okay, I'm opening a state channel with someone when I'm transacting with them.
I think in general with like blockchain development, you can just kind of think of it as like very, very low level infrastructure that no one should ever have to interact with if they don't want to, right? Like as a user of the internet, you never consciously think about like TCP IP. You never consciously think about like what HTTP request you're sending when you're opening a website or something like that. All of that is abstracted away in your browser and in your query parameters and your address and things like that. So as a user, you really eventually don't have to deal with it.
Can you talk a little bit about the difference between payment channels and state channels that are more generalizable and can allow for arbitrary complexity?
So if you think of like a payment channel as the most basic type of channel that you can have, what's happening in a payment channel? When I pay you money, Jason, I'm reducing my balance and I'm increasing your balance, right? And those are really just two numbers. And so those numbers could represent ETH, they could represent dollars, they could represent votes, they could represent reputation. So that's really cool because that means that we don't really, like we can pay each other in like any arbitrary asset, technically. But then it gets more interesting because if you're just manipulating two numbers, why can't you not manipulate more numbers? Why can't you just manipulate like the entire state history of something? In the same way that you manipulate state for like a video game or for when you use like a web app and like your state is being stored on the front end. And the question is, so the answer is you totally can. It's kind of mind-boggling because it's like you could really run anything in the contract in the channel. You could put any contract into the channel and just have it work. And so that's what I mean by arbitrary complexity. It's just like generalizability of these channels.
So it sounds to me like in the field of state channels, there are quote unquote more simple state channels that are payment channels that allow people to transact with each other. And then there are more generalized state channels that can support more complex types of transactions. For instance, it could take into consideration the logic in a game, for instance.
So the way that I have always thought about it is that there's two axes to complexity for like payment/state channels. One is generalizability. So like how much can you do in an independent channel? So like if I open a channel with you, a really generalizable solution would mean I could pay you or play a chess game or pretty much do anything I want in there with you. And then there's the other axis, which is extensibility, which is like how many people am I able to transact with without needing to open new channels? So like, in a totally extensible paradigm, I can have a channel open with you and I can transact with you. But if I want to transact with all of your friends, I could also transact with your friends through you. And so like on the one axis, there's like counterfactual, and then on the other axis, there's like Raiden, right? And so we kind of are like somewhere in between both of those solutions.
And I'd like to talk more about the differences between state channels, which is, of course, what Connext is working on, versus other scalability solutions that you talked about, like Plasma. And you mentioned finality being a huge differentiating factor. And I'd like for you to just describe why this matters from a user experience perspective.
Yeah, so as I mentioned before, I really am pretty convinced that really the fundamental difference is like whether everybody is agreeing with something or not, whether you need each person to agree with something. And the big trade-off there is like if you need each person to agree with something in order for it to be final, then that means every single person has to be online to agree with it. And it can't really be finalized until every single person agrees with it. So that's kind of a UX point of friction because like you're front loading the agreement part of it. Now, in something like Plasma, you're kind of just say, okay, there's some consensus mechanism. Sometimes it's proof of authority, and that means that people don't have to agree at all. They don't have to be available at all. Or it could be something like proof of stake, where it's kind of functions like a vote, except with your tokens, and it's like a weighted vote. There's a different trade-off there because not everybody has to be available. Now, after that happens, like after after everybody agrees on what the next state is, then there's a totally different trade-off there, where it's like for state channels, everyone has agreed, and so you can just consider that that's final. But with Plasma, the state isn't finalized until that block is published back on chain, and I think that it isn't really truly finalized until afterwards too. I think depending on the type of Plasma, that means that as a user, like on the Plasma chain, you're guaranteed to have your funds. And you're guaranteed to be able to exit at any time, but that might still take you like 7 days. Whereas in a channel, you could say, all right, I'm done, and you just leave.
So it sounds like the major difference is from a user experience perspective. If I'm paying with state channels, say I receive $10 from you through a state channel, I can pretty much be guaranteed that that transaction is finalized. But I cannot retrieve those funds that I received from you unless that state channel is closed onto the blockchain, unless those transactions are updated onto the blockchain. Whereas for something like Plasma, I can pretty much retrieve those funds and actually go ahead and spend the money that I received from you once those transactions are finalized. But the time it takes for them to be finalized usually takes a long time. So with that major differentiation in mind, what do you think are the most obvious use cases for state channels for something like Connext?
Yeah, so I think in terms of end use cases, I would say state channels are really good for everything in payments. Anything associated with payments, I think is phenomenal with state channels. So that goes from like very simple ETH payments to token payments to conditional payments like subscriptions to like gambling applications to like paid chess games or things like that. And then also includes payments of like other tokens, so like reputation or voting. And then I think Plasma and like exchange. And then I think Plasma is good for a lot of the other things that are like games, probably more complex governance, more complex gambling, things like that.
And I know there are different implementations of the state channel idea out there, including Seller Network, which we just recently talked to, as well as some other projects like L4, which is building counterfactual, and they actually just partnered up with Seller Network as well. So can you talk a bit about how Connext's implementation of state channels is different from the other projects that are out there, as well as what gaps in other projects you see that Connext is filling?
So there's only a handful of like state and or payment channels implementations that are available today. And they're all kind of targeted at different use cases. So you have something like counterfactual where you can have arbitrary complexity in your state, which is super cool. But that, of course, also means that when there is a dispute, you have to deploy all of the dispute contracts. And there's this like cascading effect of contracts that ends up being deployed. And that means there's like a very high cost to disputes. So it doesn't work, for some things where there are a lot of disputes. We spoke to Funfair about this, and they said, yeah, like in our case, there is a pretty high percentage of disputes that occur within the ecosystem, and we want them to be able to be settled very quickly and very cheaply. And so like counterfactually instantiated contracts may not work for them.
So let's take a moment to explain what this idea of counterfactual instantiation actually is, because the idea is actually simpler than it sounds. So say Arjun and I want to play a game of chess, and we start a state channel so that we can do this on the blockchain. And essentially, we are able to make all these moves within the state channel without having to pay any transaction fees, unless we want to close the state channel, for instance, if the chess game ends and we want to commit the final state onto the chain. But what about when we want to play other games? Say Arjun and I also want to play blackjack and also want to play Go. So currently, if we want to play a new game, we're going to have to update the state channel because that state channel is built for that chess game only. But every time we add a new game or update that state channel, we're going to have to commit to the blockchain. We're going to have an on-chain transaction, which means we're going to have to pay transaction fees. So in the blockchain world, to solve this problem, what we have are called generalized state channels. Instead of having state channels that are very specifically built for one thing and one app only, we have these so-called generalized state channels, wherein we can update them with new apps and new games without ever having to write on-chain. And the reason why we're able to do this is because we know that both Arjun and I have the ability to commit the contract, to write that contract onto the blockchain at any time. And hence, we're more incentivized to play by the rules. And in a sense, we're acting as if we deployed a contract without ever having to. So that's why it's called counterfactual instantiation. However, we do have to commit that contract onto the blockchain if we have disputes and we want to resolve them, because at the end of the day, the blockchain does remain our singular source of truth and our place of settlement. So what Arjun was saying is that if there are a lot of disputes on an application, then we're still going to have a lot of on-chain transactions to resolve those disputes, meaning that the problem isn't really solved in the first place.
In our case, what we've done is we use something called virtual channels. This is modeled after Perun Network's implementation, except we've modified them pretty extensively for our own purposes and to change the trade-offs a little bit. In our framework, so mostly we've kept it to like hub and spoke for now, but it'll be extrapolated to a network later. But in our framework, you just connect to a state channel hub, and that hub stakes some collateral and as kind of the cost of providing the trustlessness guarantee. And you are then able to transact with any person who is also connected to that hub instantly and for free. And that's really powerful. So for something like SpankChain, as a user, you connect to SpankChain's hub, and that means you can tip any performer in any performance instantaneously without having to pay any gas, and at like pretty much no minimal value. I think SpankChain has it at like 1 finny, but you could always go lower. And so there's what we see is like from our perspective, the trade-offs work out. So in that way, that is really good for applications. Like something like Raiden is very good for one-off payments. In our case, we're very good for ecosystem-based payments, like platforms, like Golem Network, for instance, would be a great example where there's a lot of peer-to-peer activity between independent users of Golem. Our system would end up being more efficient for that than Raiden would, I think. At least, and this is kind of the hypothesis. Really, I think ultimately it comes down to ease of integration for a developer, and like what those trade-offs end up being, or if those trade-offs end up being worthwhile when they do get down to it.
So an important part of state channels is allowing people to transact with other people with whom they do not have a state channel set up. So if I want to transact with your friend, I can transact with them through you. So can you tell us a little bit about how virtual channels approach this problem?
Yeah, absolutely. So there's kind of two strategies to the extensibility axis, right? Like you want if I want to be able to send a payment to any person on the other side of the world, and I don't have a channel open with them, I could theoretically bounce the payment to them with like a bunch of people in between. And this is kind of the same way that the internet works right now. Now, there's two ways to do this trustlessly. The first, which is kind of a framework that has been around since the Bitcoin days and is being used by Lightning and Raiden, is a concept called hash locks. Basically, what happens is if you have a friend, Jason, your friend Alice, like I want to pay your friend Alice, and I want to pay Alice through you. What I can do is I can send you a locked payment, and then you can send that locked payment to Alice, and then I can send Alice the secret to that lock. And so Alice can unlock the payment and then give you the secret, and you can unlock the payment. And basically what this stops you from just not sending the payment to Alice, right? Like, because otherwise you could just say, okay, like you could take my payment and then just not do anything with it, and you just get free money. So that's one approach. The other approach is virtual channels, or as we're calling them, threads. In this case, what happens is I have an actual channel open with you, just like I would otherwise, and you have an actual channel open with Alice, just like you guys would otherwise. And instead of sending a payment through you, I just ask you for permission to open a channel with Alice, and I say, Alice and I are going to open a channel and transact this amount of money between us, or open a thread and transact this amount of money between us. Are you okay with that? And if you sign off that you're okay with that, then Alice and I can just pretend that we are just transacting directly with each other. We can send signed updates directly to each other. And then when we're done, we can come to you and say, hey, this is what we did. Here is the proof. And can you turn this into 2 normal channel updates? And if you, as kind of the intermediary, don't do that, or if one of us cheats, or if any party really has like any sort of problem at all, like somebody's unavailable, we can always just go and take that latest state, take the evidence of the payment that was done, and like put it on the blockchain and let the blockchain be the arbitrator. So this is kind of cool because as the intermediary don't need to resolve a hash lock, which actually is can be computationally complex. And the other thing is, I, as the end party, don't need to worry about a secret. That means that we can do everything over like HTTP. We can do everything over traditional web paradigms rather than having to like create an entirely new layer for us to communicate the secret on. There's the trade-off there is like it's less complexity for you, the intermediary, and it's better for like a repeated payment. So if Alice and I are paying each other a lot of times, this is way more efficient. But the downside is that like, there's probably a limited amount of extensibility to this, where it's like, if we started adding more than 2-3 hubs in between, or like probably like 3 or 4 hubs in between, it would start getting kind of a pain to like get everybody's permission to do things. And so it's useful for certain types of use cases where you'll say, okay, well, I really need this payment only to be bounced between 2 people, rather than Raiden, which allows payments to be bounced like 7 to 8 people before it gets to its destination.
So that sounds really exciting, and it definitely sounds like a pretty unique solution that's different from a lot of the projects out there. And I know that your guys' implementation is based on the research done by a lot of other teams as well. So I'd imagine that there are new challenges coming out. So can you talk about what are the biggest challenges that you are facing?
Yeah, that's a good question. So a lot of the challenges that we faced, we've kind of only recently overcome, which is pretty nice. This is part of the reason why I'm doing an interview with you now rather than before, because before like things were on fire and we were trying to figure it all out. So I think the big challenges now going forward will be just implementation. What we're doing now is we have something that we know works, and we now need to just restructure it to the point where it's like a platform that anybody can use that's on mainnet. And so now it's just like working on upgradability and working on like security and making sure that we have formal processes for that. So that's the good thing is that's like the bad thing is that that's kind of a pain and, it takes some time to do. But the good thing is that there is an established precedent for how that gets done. And so it's less of like us trying to do research and wandering around in the dark. So I'm pretty excited mostly about getting to mainnet. I think that feasibly we can do that within the next 2 months. And we will be on testnet this week. And we'll kind of be doing like some integrations with a few people with testnet hubs this week, which is pretty cool. Aside from that, I'm pretty interested in starting to collaborate more with other projects in the space. I think the state channels design space, like the possible things that you can do with state channels and with scaling solutions in general, are huge. And so there's some really, really fascinating conversations I've had with people in the space about like, what can we try doing, or how can we like mesh our solutions together and come up with something new that has a totally different set of use cases or totally different trade-offs. So I think that's kind of the next sort of step as well.
Awesome. So for people who want to stay up to date about what you guys over at Connext are working on, how can they contact you and how can they get up to date?
Yeah, absolutely. So I would recommend checking out our Medium. It's medium.com/Connext, I think. And then I would also recommend checking out docs.connext.network. It's kind of where we're putting our growing list of documentation associated with what we're building. And then if you're interested and if you want to kind of enable instant transactions in your ecosystem around your dApp, or you want to set up a hub, or you just kind of want to learn more about the technology, you can either sign up on our website for our pilot program, or you can just reach out to me directly at arjun@connext.network.
And that wraps up another episode of the Blockcrunch podcast. Hopefully you've learned a thing or two about state channels. I know for sure I have. So if you've derived any value from this episode, or if you learned a thing or two, I would deeply, deeply appreciate if you could leave me a 5-star review on whatever podcast platform you're listening to this on. It's a free resource, and a lot of you don't know this. I am dedicating full time to this podcast, and I'm doing this for free. So this is really a passion project of mine, and all I want to do is to bring quality projects and service them out to the community. So if you want to support me, then just leave me a 5-star review. That would help me a lot in helping me bring this content out to as many people as possible. So with that being said, I've been your host, Jason Choi. You can follow me on Twitter at MRJASONCHOI, Mr. Jason Choi. And I look forward to seeing you at the next episode.